Okay, in this video we're going to look at a skill that is definitely a little bit harder than figuring out a velocity time graph from a position time graph for an object moving, and that is working backwards from a velocity time graph to a position time graph. So in this example, you see we have the velocity time graph plotted out below, and we want to map the position time graph of the moving object. Okay. Similar approach in terms of the way we break it down. We want to break our velocity graph down into segments, and then we will have corresponding segments on the position time graph to go along with it. But the first problem we have, maybe you see it right away, maybe you don't. If I look at my first segment, I have an object moving with a constant positive velocity. So I think the easy thing to see is that my position time graph would have an increasing slope like that. But the hard part is, where do I put it on the graph? I mean, do I put it in the positive position area? Do I start it at 0 all the time? Do I start it in the negative region of the graph? And the answer is, it's kind of a trick question. I don't know. I need a little bit, excuse me, a little bit of water is what I need. I need a little bit more information. You need to know the initial conditions in this point to know where the position changes from there. Because I could have a constant positive velocity from down here, from up here, from anywhere on my position graph. So let's just say, for argument's sake, this is my starting point. I'm starting in the negative position region. Okay, so from here to here, I'm moving with a constant positive velocity. Now let's just say it takes me back to my original position, or my origin. So that's an increasing straight line slope. Slope is constant, velocity is constant. Okay, so from this point to this point, now my velocity is going back towards 0. So I start positive, but I slowly change to 0. So my graph has to start with a positive slope, and then it has to flatten out. So by this point, I'm going to start positive and then curve and flatten out. So by here, my velocity is 0, my graph is flat. Okay, so from this point to this point now, I have a velocity that's increasing in the positive direction. So from here to here, I need to have a slope that's going from 0 to positive, and it's going to increase like so. Okay, so from this point forward to this point, I might have made that a little too steep. My velocity is positive, but it flattens out. It remains constant. So whatever my slope is at this point, I should make my segments here. This might be a little tough. I'm going to get off my graph. This should be a continuation of the same slope, the same velocity I was at from here to here. Now notice, I have a discontinuity here. What does that mean? That means my graph is going to have a sharp edge, a break from a smooth curve. So if I all of a sudden go from a constant positive velocity to a negative velocity that's increasing towards 0. So I have to be negative and then be flattening out. So I'm going to come with a negative velocity, so I'm going to be downward sloping, but then by this point I have to flatten out by this point here. So it's going to be something like this. Okay, so here I reach a velocity of 0, and then I go back to the negative. So I'm going to be flat, and then by there I have to, by this point here, I have to be curving downward again, so I'm going to continue like that. And then at this point, I stop changing my velocity, but it remains positive, or negative, I'm sorry, and constant. So from here to here, I remain negative slope, but constant velocity. So that's a little trickier, a little more difficult. A fact to note here is that when you look at the velocity time graph, it can't tell you anything about your absolute position on the position time graph, the XT graph. It just tells you how your position is changing. So really, this graph would look the same whether I started here, whether I started down here, right? The velocity time graph would look the same. So I could translate or shift this position time graph up or down depending upon my starting location with that initial condition. So the velocity time graph doesn't tell me exactly where I am, it just tells me how this segment looks. How does it change from here to here? All right, let's do a practice. So take a second to jot down the position time graph blank and the velocity time graph as shown with the 1, 2, 3, 4, 5, 6, 7 segments. And I'm going to give you a starting point, an initial condition in the positive x direction. That's where you start. And then pause the video, map out the position time graph, and then I will show you the solution in a second. Okay, here is your solution. Now remember, this could shift up or down depending upon the initial starting position. Notice the transitions, except for here, are all smooth transitions. Where I have a discontinuity in the velocity time graph, I have a rough corner. And that's one way you can tell or verify.